Okay, like I said, we're going to take a look at discrete random variables, right? By chance, we could double up today. Anyway, I know I didn't want earlier. It's possible to double up today, like go till 9. Of course, I'll give you a small break. Any chance earlier? Message yes or no. If you can't, you can't, right? I know it's a last minute thing, right? Message now if we can go till 9 today. I wouldn't go all the way. I wouldn't go till half 9. I'll just go till 9 for the good. Yeah? Darian and Jesse. Jesse reply. All right, let's see how far we can go, right? Darian, you can stay at all?
So I just trying to repeat what you said.
No, I just want to know if I can stay a little bit longer today. We can go till 9 today, since I missed it next week now.
Okay, no problem.
Darian, I can do that. How long I can go until then? How long you can stay until? All right, no problem. All right, so here's what we're looking at, right? Let me just get a whiteboard. Nice. So what we're looking at is discrete random variables, right? So when discrete random variables, I can't move this or something, right? So in a discrete random variable, what we're going to end up with are basically we're going to end up with values that are discrete. So a very simple example is that if I were to throw coin, right? Let's say I have two options on the coin, of course. I have heads and I have tails. Right? I have two options on the coin, heads and tails, right? Let's say, as I said, the discrete variable, discrete means it takes whole numbers only, right? It takes whole numbers only, or values, so it can either be head or tail. Then I can come up with the probability for each one, right? Let's assume it's a square coin. Then I can find the probability for each of the options of x. We know that the probability of x, when x is a head, is a half. When x is a tail, is a half. So what we developed here right? What we developed here is what we call a probability distribution. Right? So what the probability distribution is, it gives the probability of each possible value. And each possible value is discrete in this case. Okay? So each of these, those are the possible values, and those values are discrete. Okay? So if they ask for a probability distribution, all we're looking for is the probability of each possible value, in this case, head and tails, right? Of each variable. And these variables are discrete. Right? So what you have in front of you there is an example of a discrete, right, probability distribution. Right? And one of the very important things there, Fisher, is that if you were to sum all the probabilities up, of what you will end up with, Fisher, if you sum all the probabilities, what you will end up with? Hey, also moving on the mouse now. Gary, I'm still moving anything. Rabisha, what value will you get if you sum all the probabilities? Very good. Rabisha said 1. Okay, so that's the first rule. The first rule is that if you were to sum all the probability, even if you have 20 values here, and you sum them up, you should always get 1. Right? Those who write it, you can write it down. Those who screenshot it and screenshot it. Copy down fast. Right? Anybody write yourself? Anybody write it? Right, so there is something else that's important that we need to learn how to calculate it from these tables, right? It's called the expected value, or it's called the expectation. Right? And we write expectation as E of X. Right? Expectation is kind of like a mean. So the expectation is like the average value. Right? Very similar to the mean, the average value. Right? How do you find it? Real simple. You take in all the X values, multiplying it by the probabilities, and then you summon it out. Okay? Copy that down. Copy that down there. So I'm going to show you an example here using a different table, right? Of course, I can't use this because of H and T, right? But that's the way you find expectation. Expectation is like your average value, right? And actually, I'm going to show you how to find your variance one time. Your variance is VARX, and that will be right. Sorry. So your variance, I'll write the formula here for you. Variance will be E of X squared minus E of X whole squared. Right? And I'm going to show you what all that means now, right? Copy it down. Copy it down, and we're gonna try a couple examples on how to apply this, right? Right? Anybody write it? All right, so let's see if we can find expectation and so on, right? Changing this, right? How do I do that? Let's come back here. Yeah, like it. Right. So let's try an example, right? So I'll give it x, and the discrete values of x will be 1, 2, 3, 4, 5, and the probability of x. The probability will be 0.1, 0.2, 0.3, 0.2, 0.3, 0. Something. Anybody can tell me what that last value is supposed to be? I'll call the value x. What that last value is supposed to be? What do you think that last value should be? Message, please. People remember the first rule I showed you about probability. What should that last value be? Caitlin, message. Alright. No, message what the last value should be, right? I remember the sentence me alone, right? What that last value should be. It should be 1. Right. Good. Avalina there. What do you playing game again? Right. Good job, Alina. Tyler, correct. Kaylin, correct. We're waiting on Bradley, Darion, Jesse. Oh, come on now, I don't want to call all the names. Ravisha, you too. Correct, Ravisha. Correct, Darion. Correct, Christopher. Jesse, you said anything? Bradley. All right, nice. So that value, as most of y'all said, except Bradley, that value is 0.1. Okay? Because when you sum all of this, it should sum. When you sum all of this, it should sum to 1. Okay? Nice. Now let's jump into how do we find E of x. As I said, the formula is the summing of all the x values by the corresponding probability. Right? So you're multiplying 1 by 0.1, then you're multiplying 2 by 0.3, and you're multiplying 3 by 0.2, 4 by 0.3, and then 5 by 0.1. Oh, we got Trinidad. We must 50. How much is that? Anybody can do a little multiplication there for me? An addition? Do some multiplying and some addition there for me. And more again. Great, Jesse, nice. The man named Jesse said 3. Nice. Before I find variance, right? If you look at the variance formula, it has something saying E of x squared. How do I find E of x squared? Well, real easy. Sum for all x, you put in x squared in the middle. So it's x squared multiplied by the probability of x is equal to x. Okay, so it's x squared by the probability of x is equal to x. So now instead of just writing 1, you add a square by 0.1. Instead of writing 2, you square it. Instead of writing 3, you square it. Instead of writing 4, you square it. Right? Instead of writing 5, you square it. Then you work it out. And from that, we can find our variance. E of x squared minus E of x whole squared. So what you get in now, please? Sybil? Right, nice. So we got 10.4. Right? And that is it. Your variance now is 10.4 minus 3 squared, which is 1, which is 1.4. Right? Nothing blocking on the screen. I don't know why it's blocking my screen. Right? 1.4. Okay? So that's the way you work out questions like this, right? Let me see who's revised the work a little bit. How you find standard deviation?
Variance.
Right, square root of 1.4. Okay? Square root, nice, Darion. Nice 2 answers in a row, you know. In a row, right? Well done, Darion. Right, Tyler, good. Yeah. What school you go, Tyler? Tyler. What school are you going?
Ice,
What's that in here? Phoenix. Oh,
ice.
oh, just messing. I hear it so good. Why so loud? Where is this at? Okay. Tyler, what school you going? Tyler. Sweet. All right. Nice. Copy it down. So that's the way you find expectation, that's the way you find variance. Alright, let's try an example and then have some more rules to give you, right? Alright, so that's the intro into this. And when you finish, right, for those who are writing. Anybody writing still? Finish? All right. Anybody writing? Nobody writing, right? Right, we'll get one out, sign your answers, right? Um. Go ahead, try that in. Put it out. Message your values. Huh? Ano ba ito? Tank empty. Pwede pa ako. Alright, nice. So what we could probably do is who could write? Who could write from right?
Right, Tony, the
Yeah,
Dude.
good. Yes, good from now. And we can go back on the screen, we can have
okay, so
picture ID, huh? Nice. Yeah, fit what you could do is just and show what you can do, huh? Right in the screen, you have what do you rest on? I see right, huh?
wait, so I do them on the like the scroll on the
Right, you all got up at EMX, he got 2.9. All get that, nice. Right, so you have a 9.7, good. Right, that's sure. All right, nice, so you're good to go. I don't know how to shoot. You can move up there. Right, how to back up your screen. All right, nice, good. Everybody okay with that? Anybody have questions on this? Ravisha, you okay with this? Kiran? Right, so basically, that's the way you handle the first part of it, right? But there are some rules that you need to learn as well. Because there are times. Right. There are times that you would end up getting things like this. What is E of a constant? Right? So if you have to work out E of a constant, real simple. Oh wait, why is not working? Oh, you will have to shift the page a little bit, right? Right, yeah. Might have to shift your page a little bit. So E of E, if you find E of E like E of 4, it's always going to be E. So you don't stress yourself out there, right? E of E is always E. E of EX, right? Instead of, so for example, if I said find E of 3x, you don't have to go and multiply 3x by 1. You can just pull the 3 on the outside. So it will be E of x. Right? So E of EX is E of x. All right, nice. So what do you think E of AX plus B? What do you think that will be? Bradley? What do you think E of AX plus B will be? Yeah.
Um,
Write it down. And the reason why you write pen and thing right there.
okay, I was thinking maybe like, it'll be something like E,
Right. Right.
I think like, if it was like, I don't know, I think about logs,
Yeah.
but, um, something like that. Wait, I'm sorry.
What the rules are given? So
Yeah, because E of B will just be equal to B.
nice. Nice. So you'll get E of X plus B. Right? And in a similar way, we also have rules of variance. Right? In a similar way, we have rules of variance that we have to learn. Slightly different. The variance of E, the variance of a constant is 0. If we try to work it out, you'll get 0. Variance of EX, if you think about the formula is E of X squared. Right? So you'll end up with A squared variance of X. So you have to square the E and then multiply it by the variance of X. So what do you think is the variance of EX plus B? Tyler. If we can write it there from a. Tyler, you there? Tyler has left the building. Oh, no, Tyler there, man. Tyler, you can write it. What do you think the variance of AX plus B is? You can't write? Darian, you could write? Answer the same as the second rule, okay. You can write them down. Okay, so let's make a note of those rules quickly. We had a class, right? And we're going to try to apply this now. Ready? Let's go again. Where we share weekend. Weekend, all right, guys. I can show you. Here it is for us, good class. All right, so let's see what we got here, right? Let's try this example quickly. Right, let's try this example. I'm gonna format it a little bit different. Right, so for a discrete random variable, I want to seek out understanding of notation, right? For a discrete random variable, probability of x equal to 0 is 0.05. Probability of x equal to 1. If you want to put it in a table form, go right ahead. 0, 1. So I want to define E of x. E of x squared. And then see if we can use the rule that I just gave you to find E of 5x squared plus 2x minus 3. And then find variance of 2x. I try those two things with any rules that I just gave you, right? Well, 3 things, sorry, 4 things. Good time, right? Right? I just kind of create a little bit different, right? Kind of like your answers to the first 2 parts, right? Find any typical style, or it you follow the other style. Follow the others, right? So all I gave you were the options for x, 0, 1, 2. Right? And then down here is the probability. Does it? Right? And then you just follow everything from right there. Right? Same thing, I just put it a little I just give it a different form. I gave you a table. Oh, yeah, book it out. You're getting to that?
Yes,
Where you
sir,
get
send
the
him answer.
What's that?
Yes, sir, send him answer.
All right, nice. What you got for E of X and E of X squared, Kyle?
I sent him answer in the chat.
Send them up in the chats. Bradley sent 2 answers from Dyson, Bradley. 2 and Dyson?
I send you one.
You sent me 2 alone, Bradley. I have 4 there.
Yeah, I sent him all four answers there, sir.
Oh, Bradley. Oh, wait, no, that was Kyle. Okay, sorry. Wait, that's Kyle or Bradley? Okay, I now see them, Bradley. Right, Kyle sent the first 2. Looking good. You got 1.45 here. And you got 2.45. Nice. For the next one, just to make sure we do it correctly, it will be 5 by E of X squared, because I'm using the rules I showed you a little while ago, plus 2 by E of X. Remember, you can pull the 2 outside, right? And E of any constant is the constant. Right? So that's 5 by 2.45 plus 2 by 1.45, right? Minus 3. Right? Keelan got 12.15. You okay with that? Nice. Yeah, good. Right, but you follow what I got part 3 now, Jesse. And then part 4. Part going on there. There. Right, and then part 4, that'll be 2 squared by the variance of X plus 0, right? Because the variance of any constant is 0. So that'll be 4. I did not work out the variance, so I'll work it out now. 2.45 minus 1.45 squared. How much is that? 1.39? All right. 1.39. Okay, 1.39. Right? We still have one more little thing to do called commutative, and then I could give you a little break. Anybody confused? Tyler, you okay with all of this? You good? All right, nice. Kiran, you do nothing then, Kiran. Kiran, you get out of this guy. Okay. All right, nice. I want to give you one that's structured a little bit different, right? I'll give you 2 minutes, see if you can do this one. Okay, you okay with the others? You okay with part 3 and 4? Yeah. All right. So I'm going to work one a little bit different. Here's what I'm going to do, right? I am not giving you values for the probability. I'm giving you what is called a PDF. It's a probability density function. So I'm giving you a formula to help you figure out the probability. Let me see what you'll come up with here. I forgot what number we on. Let's say it's number 4, right? Let's pretend it's number 4. So given the probability of X equal to X is Kx. Let's say I give you something like that. Hold on, I just see it. Right. But that formula only works for values 1, 2, 3, 4, 5. And then the one next formula for the remaining value. A by 10 minus x is 6, 7, 8, and 9. All right, 6, 7, 8, and 9. Let us see if we could figure out this table and then figure out P. I know I didn't show you one of yet, but I just want to see what you come up with. So see if you can fill out the table. And if you figure out the table, you can find K. Okay? So find K from now. I just given you a little help out here. It's not looking like help, but it's what I could really all right. Do your thing there. See if that can help you find K. If you can't, I'm giving you 5 minutes. I'll wait for 5 up there a little bit, and then we will see. Okay. See if you can find K using those two little formula there. If you get any message value from K, right? I want to do this now. See some values coming already. Any more? I see two so far. Then I'm trying this now. Anybody else? Darren, anything, right?
100 seconds, 1 second.
Again, do you think? Alright? Let's go at it. Let's go. Let's do it again. So when when x is 1, I'm using this formula here. So again, k. When x is 2, I'm using the same formula. When x is 3, same formula. X is 4, up to x is 5. Now, when x is 6, I'm using this formula underneath here. Right? So that's 6 minus 10 minus 6 is 4. So that's 4k, then 3k, 2k, and then k. Now, if I add up all those k's supposed to be equal to 1, then so that'll be 1, 2, 3. So adding up k plus 2k plus 3k plus 4k plus 5k plus 4k plus 3k plus 2k plus. Right? 1, 2, 3, 4, 5, 6, 10, 25k. So when I add up all of that, that's equal to 1. So it means that k is equal to 125. Follow that? So instead of me giving you a probability distribution table, I gave you what is called this here. This is called a probability density function. So I gave you something called a PDN. You okay there? Any questions, anybody? All right. Take a little break and then we're going to do some past papers in it. And we have one more thing to look at, right? It's called cumulative function. So just like cumulative it up. All right, Dario. All right, take a small break. We take a 5-10 minutes, 10 minutes, 9 minutes. 8 o'clock, we start back again and we're gonna take a look at some questions, right? I would take you all the way till 9:30, right? Because you all kind of know this already, so I'd rather go it over like next week. All right, Darren. So let's just go and do some past papers and then I'm gonna do cumulative and finish up this part of this school. All right, let's go again now. Right, so before we jump into the papers, I want to do a few things, right? Let's do my favor and just message. Yes, I know you're there. Just message yes, I know you're there, right? Right, to start back. No, not back. Yes. Okay, okay, some people. Some understand, right? Alright, start about the Q on you there. You'll be sure. Are you there? Alright, so before I move on, right? Before I give you the past paper, there's something that we need to understand, right? There's something called the cumulative distribution function. Right, so watch this here. Right, so as I said, we're taking a look at something called the cumulative. Right, you might need to adjust the thing a little bit so you'll see my right? Right, so as I said, we're going to take a look at the cumulative distribution function. Very similar to when you do a cumulative distribution, with like a cumulative frequency in 4.5, very similar to that. So if I give you something like this, right, x is equal to 1, 2, 3, 4, and 5. Let's say I give you values like this. Right? Let's say I give you a table like this, right? Remember, this is a distribution function, right? Right? A probability distribution, sorry. I'm going to say this in the cumulative, right? So what does the cumulative mean, right? So if you see the symbol capital F, if you see the symbol capital F of x, that's a cumulative function, right? So what does that mean? So the cumulative function f of x simply means the probability of x less than or equal to x. For example, here, I want to get the probability that's less than that x is less than or equal to 1, which is 0.05. Here, I want to get the probability of x being less than or equal to 2. So because it's less than or equal to 2, I have to include 2 and I have to include 1. So when I add it up, I'll get 0.35. So accumulating it now. So next one will be the probability of x is less than or equal to 3. When I accumulate it, I'll get 0.75. 4, that'll be 0.9, and 5. 5, once done properly, should always be 1, right? Here should always be 1. That's it. That's all. The difference now is that if you see capital F of x in a question, you have to know that that represents cumulative distribution function. So you can't use this second table here and then go and find E of x. You have to take second table and recreate the first table. And then go and find anything in it. Okay? So again, all we're doing is accumulating all the probabilities before it. All right, Kyle, you okay with that? Kieran? That's all they mean by cumulative function, right? Rabisha, you okay there? Yeah, all right. Right, so I don't want to tax all the brain too much again, but nothing new. All we're gonna do now is see how the past papers bring it to us, right? That's all. So I want to see what the lives see, right? I want to see what screen the lives see. Oh, it's the live on this. Wait, the live see my wife on my iPad. So, all right. The live not showing what I see on TV. Anyway, I hope the live had all the things right. All right, let's go with the child people from the past. Right now, all the past we can do again, right? Yeah, I'll show you this subject. Well, after you can figure it out. Right, try this here first. Try that first. 1 minute again. Right, so they make it nice for you. You don't have to go and find E or Y and variance or Y, right? Anybody else missing the answers? All right, let's see what you got, right? So this will be equal to three E of Y plus two. So that's 3 by 3.8 plus 2. What's that? 9 to 11.13.4. Get up to 13.4. Yeah, nice. I in a similar way, we will work out variance of 3y plus 2. That's real simple. Use the formula I gave you. Right? Once you have a 3 constant, sorry, 3y, that'll become 3 squared by the variance of y plus 0, right? You don't have to write it plus 0, I just write the typical reminder, right? So that'll be 9 by 2.16. And you're good to go. 19.44. Right? 19.44. Right? Nice job. $19.4. Right? Any questions? You're okay with that? Let's go to our next one. I think that this was 2019, right? Yeah, it was 2019. Let's go to our next one. This one is 2021. Then basic sum. They want you to find E. Sorry, they want you to find B. E of X, variance of X. Take your time. Right, find E of X and variance of X, right? Kiran, I'm waiting on you this time, right? Some answers. Tyler, you too. Right? Get through. Named Kiran. Kiran. You have the key and your ran. That's something that the sign Kiran. Where are you, Kiran? Did you run with the key? Run. Nice key. Run. Okay, nice. First thing first, find B. Well, basic stuff. Right? So all you have to do to find B is add up this, add up B, add up 0.2, make it equal to 1, and make it something, right? So what is that? That is 3, 4, 5, 6, 7.5. So you all got 0.25. Right, 0.25, something good. Next, remember you have to get variance too, eh? I know I'm not showing it there, but you still have to get variance, right? You have X. Where is your Visha's answer? Visha, you tell me what you get for variance, please. Right, check it back quick. I've seen some different answers of E of X, right? So let's check it back now. Wait, none of Visha answer. Right, again, 2.9. Hey, look for Visha. 2.95. Right, find E of X squared and then find variance, please. Find E of X squared and then find variance. Right, what shall get E of X squared? Right, good. Message answer. Message answer. Alright, nice. So from what I'm seeing, E of x squared, 10.35. So that'll be 10.35 minus 2.95 squared. And was that 1.65? Anybody got a variance? 1.65? Yeah. All right. All right. One more close up the brain then. Let me see if we can close up the brain a little. Right. The other three past papers are like discrete variable, right? Sorry, continuous something and distribution. I didn't show you that again. But what I didn't get to do was to show you. If you have fully worded question. Let's see if we can try this question. It's fully in words only. Last one. Last one we do it, right? So you have to take the info, of course, take the info, and let's see if we can create a table and then find everything that we need. So hard thing here is to create that table. So first thing you have to do is figure out X. How many discrete values do I have? 1, 2, 3, and then figure out what they are. Then find the probability of each case. Right? If you want to do a probability tree, you can do it to work out the probability, but you don't have to, right? Anybody think they have it? Anybody think they have it? Jesse, you want to help me a little bit?
I don't finish. But I could tell any what to do for the table. I didn't feel
Yeah.
good.
You know what, help me first.
Sorry, sir.
Yeah, I want to help with the table first.
Okay, well the X values you could just go from you could either pull no red disk, one red disk, or two red disks. So 0 to 2.
Right, so what's the probability again? Two red lists. Sorry, no red list.
And I now started to do a probability tree to without
Okay, okay, so what does no red mean? No red means two whites.
white and white.
White, right? So what's the probability again a white?
Uh 4 and 7.
Right? What's the probability again a next white?
3 and 7.
Right?
No, 3 and 6.
Six. Three and six. Nice. That's it. Yeah, multiply the two of them. And then work out two red and then you can figure out the next one. Right? So the probability again, no red means they get two whites. So a white is 4 and 7 on your first try. And remember, you're not putting it back. So you have one less, right, Kyle? So you have one less red, one less white, and one less in the overall, right? So that'll become 3 out of 6. You multiply that, and you get your answer, right? That's what, 2 and 7. Right, do all the thing, finish our table. And then of course, once you get the table, the expectation easy, right? But be sure you follow what to do. That's the very table. Table is the hardest part. Right, let's see what you got. And instead of working out one, I'm going to two, right? I'm working out two first. Two red will be 3 out of 7 multiplied by 2 out of 6. Okay, so I got what? How much is that? We did this one, I got 1/7. So by working out 2/7 and working out the 1/7, probably I am properly, I'm able to see that that for one it should be 4/7, right? So for one, it will be 4/7, right? There's a white and then a red. Then 3 out of 6. And then adding that up, you gotta do it twice. You can get a white and a red, then you can get a red and then a white. So it's 3 and 7 by 4 and 6. Right? So the table probability will be 2/7, 4/7, 1/7. You okay with that? Follow with me still? Jesse? Follow with me still there? With Bishop? Yeah, follow with me still, everybody? Right, so you notice I didn't work out, I didn't have to do all three, I could do two and work out the next one, right? So I found two white and two red to be the easiest thing to work out. So I work out those first and then I work out one only. Right, and then do the last part for me. If everybody answers, we can stop here. And we have one more question to do, but I'll give it for homework, right? Do this last part here for me, please. Right, but I want to see answers from all 8, 9, 10 people. How many people are there? Take your time, work out expectation and standard deviation. I think we get 10 answers. Work it out first and then message both answers, right? So sometimes it's tricky, like check when you get questions like this. You want to make sure you take your time and work your probability out properly. But the best way to do it sometimes is some form of diagram. So in this case, the best diagram would be a probability tree diagram. Because you may have missed out red, white, and white, red. Alright, so we'll go this. Could we share with us though? Okay, so we'll go this last part here, right? How much we have so far? We have 6 answers with none, 3 people. 3 people. Right, we still have one more class to make up here, only because although I'm missing on the next week, the week after I'm not here too, right? I'm not here for, well, I'm here for 1 week, but I'm doubling up with somebody else. And I'm not here the week after, right? So we just have one more to make up. Right, but we go going good. We done module 1. We enter the second part in module 2. All right, so expectation 1.14, 8 on 7, or 6 on 7, 8 on 7, right? Nice. And then you will out your variance and square root it, right? So I've seen some people got the variance as 20 and 49. Right, 0.64 is the right. And you can put that. All right, good. All right, nice. So that's where you have questions like this, right? So what you should do, don't wait on me to give you a summary, right? Don't wait on me to give you a summary. What you should do is do a small summary of what you did so far. So write down the rules of probability, write down the rules of discrete, right? I will give you one, but at the end, right? So all we have to look at next is that the way these probabilities in some examples are found, they follow a particular distribution or they follow a particular pattern. And we call that pattern a distribution. So we have to learn one particular distribution called the binomial, right? But I know what it is quickly, right? So I wouldn't squeeze it in now. But if you want to read up on what we're doing next, we're gonna take a look at a special distribution called the binomial distribution. It's a special type of discrete distribution, and it allows us to find values for probability using that distribution. All right. Oh wait, I'm not saying we're gonna stop. I won't kill it. Right? I wanted to do one with like cumulative, right? But okay. I should be able to handle it once you all see the capital. Right? But we'll do any. All right. The correct thing to do is that we just do one. But I will do it together with you, right? I will do it together with you. So here's what I'm giving. I am giving you what we call, right? Once you see this f of x, you know what I'm saying. It's a cumulative distribution function, right? I want to do one example like this. Right? And I'm making it short, just 4 values. 1, 2, 3, 4. Right? This value is 0.13. This value is 0.54. This value is 0.75, and this value is 1. All right. So all we have to do, all I wanted to do, I want nothing complicated. All we are going together is how to get the probability distribution back from the cumulative. Okay. So anybody can tell me based on what we learned, what's the probability of 1? What will be the probability of 1 here? Last thing, so once all the message we done, what's the probability of 1 given the cumulative distribution function? Right. Same value, right?
0.13.
Yeah. So when x is 1, it will be 0.13. Now, what is the probability of x is equal to 2? Once you figure that out, you'll figure out all the rest.
0.41.
What would it be? Very good, Elena. Elena said she said 0.54 minus 0.13, right? Which is 0.41. What's the next one? Next one. Bradley, number 3, and we done.
0.21.
You sure?
Well,
Nice.
yeah.
0.21, right? So you're minusing this and this. And last one. Last one, Kyle. Last one, Kyle. What's the last one? Right? 0.25. And negligible. Right? Just add up all and make sure you get 1. Right? And that's it. Right? So sometimes you see questions and it's not as popular. Right? You don't see it as much as what we're going to do next. So next day, we will focus fully on the binomial distribution, right? So what I'll do is I will send a message on the group and we will just see what day and time convenient for all, right? Any day next week, we could do it, right? Well, except Monday. I could even do it late next week, 8 to half 9 or something. But I know they have class Tuesday, so. But I'll give you a few options and you'll let me know which day, right? All right, so now